Okay, so in the second scenario, we are going to suppose that this person 1 and this person 2. So we are going to suppose that person 1, she's going to jump right here to point B, and this is going to be our starting point, point A again. And so it's going to tell us that this was an 80 feet jump, 80-foot jump, yeah. And so person 2, right here, she's going to jump straight down at 75 feet. So we will label this point C. Okay, and so our objective for this problem is to solve for the ungiven lengths and angle measurements. So right here, also in the problem, it tells us that angle BCA is it tells us that it's a 90-degree angle, so this is a right triangle. And so we need to find these two angles right here. So we need to use an inverse sine. So we're going to use inverse sine, and that is an inverse trigonometric ratio, abbreviated as sin -1. And so we know that sine is so in a right triangle, it's the ratio of the length of the opposite side divided by the length of the hypotenuse. And so the inverse of sine is kind of going to be like the opposite. So instead of having sin and then the angle equals the ratio, it's going to be the inverse of sine, the ratio equals the angle. So we're going to do sine -1, and then we are looking for the ratio. So since we're doing for this angle, it would be 75 divided by 80. So put your little feet over here. And then is equal to, we'll call this x, is equal to x. Okay, and so then we can then plug in the inverse of sine. 75 divided by 80 is equal to x, and so we get that x, we'll round it to the nearest tenth, so x is about 69.6 degrees. So the angle x. So we can put this in like a little section of things we didn't already know. So angle x is about 69.6 degrees. So that was something that was not given to us, and so therefore we can use that to find angle y. So we know this is 90, angle z, we know that's 90 degrees, and we know that angle x is 69.6 degrees, and that therefore angle y would then be, so we can add these two up, 69.6 degrees plus 90, and we get 159.6. So do 180 subtracted by 159.6, and we will get that angle, the measurement of angle y is equal to 20.4. Okay, so now we have all of our angles, so we can use these angles to help us find this, the measurement of this line right there. So for this one, we are going to use the tangent, which is in a right triangle, it's a ratio of the length of the opposite side divided by the length of the adjacent side. And so we are going to set this up. I'll use the red marker. So we are going to do tan and of our angle, which is B, is the one we're going to use. Well, it's angle X, I'm sorry, angle X. And so we see that is 69.6 degrees. And then, so since tan is O over A, and this is the opposite side, and therefore this one is the adjacent side, and that's the hypotenuse. So we're using these two sides. So 75 over, we'll call this something crazy, F. Okay, so now we're going to multiply each side by f, and so we're going to get tan of 69.6 times f is equal to 75. I hope you can see this, but anyway, and so since we have to get the f alone, let's divide these sides by tan of 69.6. And do that to both sides. So tan of 69.6. And so we are going to get that the f is about, let's see. So plug it into your calculator, 75 divided by tan of 69.6. And we're going to round to the nearest tenth. So we're going to get that f is about 27.9 feet. So we can put that in this little box right here. So f is about 27.9 feet. Since we're already given these, and we found the ones we weren't given. So that's it. I hope you enjoyed.